Dear students, in this video I will explain you chapter 13, that is motion and time. So you can open up the book so that we can see together, we can read together. Let us see what is motion and what is time. So motion, motions, the movement of an object from one place to another is considered as motion. For example, when we kick the ball, as long as the ball is in the air, that means the ball is in the motion, and when it comes to the ground and when it stops moving, there is rest, no more moving. So any moving object is considered to be in motion. We can see some example here. Example of motion: car, moving car. Earth is moving around the sun. A running man. So when we run, we are in motion. Moving car is also in motion. These are some of the example of motion. Now let's erase in motion. Just read here. A body is said to be at rest if it does not change its positions with respect to its surrounding. So anything, any object is said to be at rest if it does not change its positions with respect to its surrounding. Example: you just keep your book on the table, and then the book will be on the table as long as you took and keep some more. Likewise, you just sit in your home for the whole day without moving, or you just sit in your home without moving for like 2-3 hours. That means you are at rest because your positions does not change with respect to the surrounding. That is called rest. And then motion: a body is said to be in motion if it changes its position with time in relation to its surrounding. So any object is said to be in motion if it changes its positions with respect to its surrounding. That means you just run from your home to somewhere. That means you are in motion because you already changed your position. You kick the ball will be the ball will change its positions when we kick the ball. So that means as long as the ball is moving, the ball is said to be in motion. Let's see now mechanical motion. What is mechanical motion? I will just give you an example. Suppose you are traveling in a car. You are sitting in a car, you are at rest, but the car is moving. So the person sitting next to you, you are at rest in relations with the person sitting next to you, but you are in motion in relation to the surrounding, to the roadside, the trees, the mountains. So since you are traveling in a car, the trees and the mountains are moving backward. So in relation to the mountains and the trees on the roadside, you're in motion, but you're at rest in relation to the person sitting next to you in the car. That is called mechanical motion. I hope you got my point. That is the mechanical motion. Now let's see speed. What is speed? The distance or distance traveled by an object in an unit time is called speed. So, for example, the distance between your home and school is 50 meters. So, to reach school from your home, it takes 10 minutes. That means you're covering 50 meters in 10 minutes. So that is what we call it speed. So to find out speed, we have the formula here. Speed is equal to distance covered divided by time taken. So this is called speed. Now let's see uniform and non-uniform speed. The speed of a body is said to be uniform when it covers equal distance in equal interval of time. So for example, this distance between your house, your home and school is 50 meters. So to cover 50 meters, you spend 10 minutes. So today you spend 10 minutes to reach school, and tomorrow also you spend 10 minutes again to reach school, and the next day also you spend 10 minutes again to reach school. That means you spend 10 minutes to cover 50 meters every day. That means you're in uniform speed. Your speed is in uniform. But today you spend 10 minutes, tomorrow you 15, and the next day 20 minutes. That means your speed is not in uniform, because every day the time taken is different to cover the same distance. We will see more example here. You can see example here. A car is moving. This is time in minute, and this is distance in kilometer. So the car is started moving from 6 a.m. exactly, and in 6 to 6:15 it cover 5 kilometer, and from 6:15 to 6:30 it covered 10 kilometers. That means in every 15 minutes the car is covering 5 kilometers. That means this car A is in uniform speed. And for car B, it started moving from 6 a.m. exactly, and in 6:15 a.m. it covered 10 kilometers, and in 6:30 it covered 15, and then in 6:45 it covered 30. That means this car B is not in uniform speed, because in the same timing it cover different distance. That means this car B is in non-uniform speed. Now let's see time and its measurement. Time and its measurement. What is time? Time is a very important factor of life. Time is the interval between two events. So time is very important in our life, because in everything we do, we look at our time and we measure the times to do any activities. So time is the interval between two events. So for example, it took approximately 12 months to celebrate Christmas every year. So this year we have celebrated Christmas in December, and next year we will celebrate Christmas again in the month of December. So it is the interval. Time is the intervals between two events. So how do we measure time? How do we measure time? You just see here, the SI unit of time is second. So we measure time by counting the second. Just look at the table here. SI unit of time is second, so we measure time by counting the second. 60 seconds equal to 1 minute. 60 minutes equal to 1 hour. 24 hours equal to 1 day. 30 days equal to 1 month. 12 months equal to 1 year. 10 years equal to 1 decade. 100 years equal to 1 century. 1,000 years equal to 1 million. So this is how we measure time. So what are the different devices we use to measure time? Let's see. One is sundial. This is also a device to measure time by using the positions of the sun. And the next is water clock. This water clock is also a device to measure a time. And sand clock or hourglass. This is also a device we use to measure time. And then spring control clock, battery quiet clock. These are some of the devices we use to measure time. Again, now let's see a simple pendulum. Simple pendulum. So in these simple pendulums, we have metallic ball and a string. So you just look at the diagram. This is the bob or metallic ball, and this white one, this is the string. So here in this simple pendulum, you just pull this metallic ball. You just pull this metallic ball to the side and just really release it. Then this metallic ball will swing back and forth. It will swing back and forth. So the time taken to swing back and forth, time taken to swing back and forth of that metallic ball is called time period. The time taken to swing back and forth of this metallic ball is called time taken. So the motions of this pendulum, the motions of this pendulum is called periodic or oscillatory motion. Periodic or oscillatory motion, because this metallic ball is swing back and forth at the same timing. That is why it is called periodic or oscillatory motion. So this simple pendulum, this is also can be used to measure time. Now let us see distance time graph. In distance time graph, it will show the distance covered by any object like a moving car, and at the same time it will also record it, or it will also show the time taken. So let us see some example here. Let's see, this is the y-axis and this is the x-axis. So this x-axis represent time in second and y-axis represent distance in meter. So for example, here is a car, and the car is started moving from here, from the zero, and it cover up to 30 meter. So 30 meter 3. So in 3 seconds the car covered 30 meter. So this time graph, distance time graph, represent the distance covered and the time taken to cover that particular distance. This is called distance time graph. So thank you. This is the end of the chapter. I hope you have learned something from this video. We'll try to continue in the next video, next chapter. Thank you.